Hi, I'm Jeff, and I'm going to talk about how to compute an inverse element in real case. So the intuition of this topic is because I was implementing the Start 101 from Python to Rust. So that's what I'm going to demo next week. But for now, I'm implementing the field element for now. And I found, because I didn't know how to implement the inverse of an element. So that's why I got into this topic, right? So maybe let's talk about what is inverse. So inverse, I think the definition is like this. We want to get the inverse of A. The inverse of A, let's talk about A minus 1. So this is the inverse of A. It should be the identity element of the, whether it is the field or group. Yeah. And yeah, how do we get this? For example, if we are in a multiplicative group, the first method to do so is called extend Euclidean algorithm. And the second one will be Fermat-Little theorem. So let's talk about this one first. So this one, you might, I think all of you might heard this before. The Euclidean is just, you want to get the GCD of two numbers. But extended will be like, after you do the GCD, you can also find the inverse of it. So maybe we want to have, let's talk about the real case. So we have element 17, and we want to get its inverse, which will be like this, and maybe like mode 43 here. Yeah, how to get this? So let's use the Euclidean algorithm now. So first we do things like this. So now we want to get the lowest number that calculate by 17, but the result will be, the remainder will be also positive. So this will be 2 here. And the remainder will be 9. And let's get these two numbers down to here. So 17 will be 9. So this will be 1 and 8. And we get these two go down here, 9 and 1 and 1. And now we know the GCD of 17, 14 will be 1. Yeah. And then now comes to the extended Euclidean algorithm. So here we put, it is kind of a reverse engineer. So we put 1 in the beginning, and then we will get, we put we'll minus 8 here. So we'll get 9 minus 8. And then this is first one, second one, third one. And we can use the second one to calculate 8. So we just put 9 to here. So 8 equals to 7 to 9. And for the first one, we also want to calculate 9 equals to 43 minus this. All right. Now we can put it, we can replace 8 using this. So now we get 1 equals to this. Right? So we replace 8 to this. And now we can recalculate it to like this. And then we also want to replace 9 with this here. So we replace 9 here. 1 equals to 2. This one, 43 minus 72 minus 7. And in the last, we will get this minus 5, 17, and 14. And there's actually the result of this algorithm is that if GCD A and B equals to n, and you will get integer s and t such that s a plus t b equals to n. So in our case, we got the n is 1. So this will be s, this will be s, and this will be the t there. And the 1 is n here. So that's we can get the formula of that. And remember, we are molding 43 here. So we can just put it, we just ignore this. So that we can get 1 will be like this. But we always want to get the positive integer here. So this will be 43 minus 5 equals to 38. So now we get the inverse of it, so which is 38 here. Yeah. So this is the extended Euclidean algorithm to get the inverse from the beginning. And now we come to the second one, Fermat-Little theorem. So this is much easier. So the Fermat-Little theorem will be I'll use another marker. Yeah. So P is prime, and we can get A for any integer A. This is an integer. We can get any integer A such that A P will equals to A mod P. So how do we get the inverse of A? This is the element we want. So we always want to get the A inverse here. So how do we get this? We actually can because if A is not divisible by P, we can divide it here so that we can get this mod P. Yeah. But in this case, there's no inverse here. So how do we get it? We can actually put A and multiply by P minus 2. So that is the inverse of A equals to 1 mod P. Yeah. So there's actually 2 algorithms to do so. So first is square and multiply. And I think the other way will be add chain. I'm not very familiar with the algorithm, but you can check out the terms here. And the add chain will be represent like x, I think x2 equals to x1 squared plus x1 squared, and x3 will be x2 squared plus x2 squared here. And the reason we are going to find this is we want to find the shortest add chain here, and there's no like the algorithm we know about to like really optimize to get the shortest add chain here. So there's still something we can research for it, or I don't know. Yeah. And you can check out, there's actually a library on GitHub. You can use the CLI and you can actually type some like the curve you use or the element you use, and you want to get the action of it. Yeah. So I think that's all for you to how to get the inverse of an element. Thank you.